Tyler, you can hook up an ICE vehicle, obviously, you can scan it for codes. You can also scan an EV today. What's the difference in that? Do you get more information out of the ICE vehicle than you do the EV at this point?
Well, the base electrical architecture from communication and code standpoint is all at the same level. So you can get a lot of the same information, but the one difference is with like an EV vehicle is that since everything is electronic, you've got control units for everything, you can do a lot more tests using the diagnostic equipment. So there's less mechanical testing. It's much more run the diagnostic routine, and it can tell you, oh, I need to do a reconfiguration of something. Maybe the internal diagnostics indicate a problem. So basically, you've got a better window, I feel, into the system. With our equipment, we can do anything and everything we need with the car. And then if it's something that needs to be escalated further, then we also have retailers to step in. And then basically it goes from the retailer software up to level of like engineering software. So then they can get really far into the details.
How has OBD made the job of the technician easier for internal combustion engine vehicles? Somebody comes in with a check engine light. How has OBD helped you?
I would probably be the biggest fan of the amount of diagnostic codes and the information you can get for vehicles. I mean, it's no longer guesswork. It's all detailed fault tracing and with codes to follow that'll tell you right when a fault has occurred. You can fetch that information, you can analyze it, and then you can go to the live readout and take a look and see what's going on. If you can pinpoint when it happens, then you can pull as much data as you can, and having all that information is really helpful in the name of being able to understand, especially on a complex system like a modern gas engine and or an electric vehicle. It's no longer guesswork, right?
So generally speaking, it helps you fix the car right the first time and quicker too, right?
Yeah, absolutely, immensely. Just because you can pull from so much and you can look and you can analyze rather than it being strictly, what the industry came from was strictly mechanical tests, right? Mm-hmm. It was check with gauges, do basic mechanical setups, adjustments, things of that nature. I mean, even on Volvo, say, mid-90s that I've owned myself, it was all, or a lot of mid-90s vehicles, it was all, and that's not that old, right? But it was electronic, but still a lot of base mechanical setups. Now everything is, electronic calibration. So the base is handled by the control unit. And then from there, if it goes outside the operating parameters, that's when it throws a code. So then you look at what outside influence may have caused the system to run incorrectly. And the codes can, obviously help you determine that. You've got like a system 2 lean code, you're probably looking for an air leak. So you might have to do, that's probably the difference between electric vehicles and gas. You still might have to do an air leak check on the intake system, right? Mm-hmm. To find an air leak or a boost leak. But you may be looking at more of a sensor issue or a component failure, like leaky fuel injector causing rough running, right? Mm-hmm. But that's something on a high pressure fuel rail, you have fuel rail pressure sensor. So you can key the car up and you can verify that fuel pressure is dropping. It's no longer hook a gauge up, right? We have a sensor for that, so you can monitor that and take a look. And moving from that over to an electric vehicle, it's completely electronic. So there's no air leak to look for.
When it comes to EVs, how would you sum up today's diagnostics from what you've experienced? Is it thorough enough for you to work at the same high efficiency level as
Absolutely. The fact that an electric vehicle is no longer, as I call them, like a mechanical animal, right? It's purely digital and electronic. So you're just really dealing with electrical fault tracing as your predominant mode of diagnostics and repair. The nice thing is that, the vehicle is, there's hardly any mechanical systems on it. For me, I find working on the electric vehicles to actually find them to be easier to work on, a lot more straightforward. I mean, I get the luxury between Volvo and Polestar is strictly just electric vehicles, and the most part, I find the Polestar is quite easy to maintain and repair. And, there is less maintenance that goes into them. Yes, they do break occasionally and you'll have codes, but it's like, I just find it so much more straightforward.
So there's a standard onboard diagnostic system that's coming for all brands of EVs in 2026. How do you think that's going to affect the way you do your job and maybe other technicians out there?
I think if it's a standardization, it'll make it easier for any qualified technician to work on any make or model, right? If you have the high voltage training, then you'll be able to pull codes that may be more familiar to you.
Mm-hmm.
So I think that could be a big benefit in the industry. I know I would agree standardization, if possible, adds convenience and makes things a little easier because then everything's speaking the same language, right? So the codes you pull on a Volvo might be the same as a Polestar or a Tesla or like a Rivian or something like that.
Mach-E, Mustang or something.
Exactly. Yeah. Porsches, all that kind of stuff. So, because the OBD protocol originally was standardization of codes.
Right.